Question number 6 in GATE Academy material. It is 2005 1 mark question. The question is, in order to have interference fit, it is essential that the lower limit of shaft should be. Options are greater than the upper limit of hole, lesser than the upper limit of hole, greater than the lower limit of hole, lesser than the lower limit of hole. As we know that the necessary condition for forming interference fit is, it's what he is asking. So necessary condition is lower limit of shaft should be greater than the upper limit of hole. So option A is the answer. So lower limit of shaft is always greater than the upper limit of hole. It is to form interference fit, otherwise it won't form. So answer is A. 1 mark question. Next topic is shaft notations. For example, 50 H7 D6. This represent capital H. 50 is a basic size. Basic size or baseline where we measure from all dimensions. H is the fundamental deviation of hole, or hole. Capital H represents hole, fundamental deviation of hole. 7, that 7 is grade of tolerance of hole, grade of tolerance of hole, which is called IT7. So in design handbook you will have values for IT7 and IT8 correspondingly. Similarly, small d represents shaft dimension, fundamental deviation of shaft. And similarly 6 represents grade of tolerance of shaft. That 6 represents grade of tolerance of shaft. Similar to IT6, you have to check the what is the value for IT6. That much tolerance we need to give. So to understand this, what is the fundamental, there is one chart in design handbook which you have to know that. So the whole dimensions always represented in capital letters. A, B, like A, B, C, D to Z. I am writing a few of them. A, B, C, H. Similarly here, shaft dimension, small letter A, small letter C, small letter F, small letter G. So it will go like that. Small letter similarly shaft will, this area shaft will be lower down. So these A, B, C and H I K, like till Z. Similarly, this A, C, F, G, J, Y, all these small letters are for shaft. So if you look this till here, it is clearance fit. So this area is clearance fit. And transition is combination of the both, and this one is interference fit. So whenever, suppose if you take the H7D6, H7D is less than G, so it is clearance fit. So even if you look at this basic size line, the values of holes are upper side of the basic size of the line in clearance fit, and they are going downside of the basic size line in the interference fit. That means the hole size is bigger in clearance fit than the shaft. Similarly, the hole size is smaller than the shaft size in interference fit. It's simple. If you understand this, then to calculate the tolerance, there is standard tolerance unit I equal to standard tolerance unit. These are all for descriptive problems. Sometimes they ask, sometimes they won't ask. They will give the all values I equal to. So there is formula I equal to 0.45 cube root of D plus 0.001 D mu microns. So microns 10 power minus 6 meters. So what is D? This capital D. Capital D is equal to the mean of diameters D1 and D2. So in problem they give the diameter varies, diameter lies in D1 and D2, step of D1 and D2. So that's why you have to take geometric mean of those. Whatever value you will get, you have to use all those in calculations. That's about D. And suppose for example hole tolerance, the same problem. Equal to IT7 equal to, from design book it is 16I. 16 into whatever value you will get from I, you have to calculate and substitute here. For fundamental deviation also, sometimes he will give in problem. Suppose for example here in this shaft deviation is equal to minus 16 d power 0.41 mu meters. So microns, it's also in microns. So you have to be careful in units in calculations, and as well as you have to be careful about the formula what you are substituting. So then you can, they never asked this descriptive question, only they asked only once for 2 marks, and that's why it's better to know that even in case if they ask descriptive question also. So we will solve the question. There are 2 questions similar to that. Question number 15, 2 marks question, gate 2000. A fit is specified as 25 H8E8. The tolerance value for nominal diameter of 25 in IT8 is 33 microns. So tolerance value for for IT8 equal to 33 microns. He has given tolerance value. There is no need to calculate by using the formula. So fundamental deviation of the shaft is minus 40 microns. Fundamental deviation of shaft is equal to minus 40 microns. So negative means it is below the reference line. What is maximum clearance of the fit? So we need to calculate maximum clearance. So first of all, you need to draw the diagram how it looks H88. So we know this is basics line, and we need to draw H88. So he is asking maximum clearance. So on the shaft deviation he has given, fundamental deviation means minimum deviation. So shaft is below the reference line. This is shaft. This is shaft tolerance, and the deviation is, this is shaft deviation or fundamental deviation. Which is minus 40 microns. So this part is shaft tolerance, which is how much? It is 33 microns. Similarly for hole he has not mentioned anything deviation, so fundamental deviation for hole is 0. We have to take blindly. So what is tolerance for hole? See, here we have to remember that IT8 he has given. IT8 33 microns. So for hole, tolerance for hole equal to hole H8 equal to IT8. So he has given 33 microns. Similarly, tolerance for shaft, same, E8, shaft is E8, so that 8 is IT8, it is equal to 33 microns. This is the logic you have to remember here. If you know this, then you can solve the problem, otherwise it's not. So tolerance of hole, how much is that? 33 microns. So now you need to calculate what is this is upper limit of hole, lower limit of hole, upper limit of shaft, lower limit of shaft. So for maximum clearance is difference between upper limit of hole minus lower limit of, that is a maximum clearance. So this is a maximum clearance. So if you understand this, then you can solve any problem. This is maximum clearance. So to get that value, so maximum clearance equal to, so even though negative values are there, but you need to add them all. So 33 is hole tolerance plus deviation 40 plus 33 shaft tolerance. So hole tolerance 33 and deviation, shaft deviation and shaft tolerance, which is 106 microns. So answer is D, which is simple, 2 marks. But only thing is, you have to know the IT8 means tolerance, both have same tolerance, so we need to take this one. So the even though the negative value is there, you need to, because the maximum clearance is that one, you have to add all those things. If it is minimum clearance, then it is 40 microns. Minimum clearance equal to 40 microns, which is called fundamental deviation of shaft. That is the minimum difference between the shaft and hole. This is simple question. Questions will be like this only. Question number 3, GATE 2009, 2 marks question. It's actually descriptive question. In generally in exams, BTech exams, you will get for 15 marks and 20 marks, but they gave it as for 2 marks. So only thing is, you need to calculations you need to do. So what are upper and lower limit of the shaft? He is asking upper and lower limit of shafts. What are upper or lower limit of shaft? Represented by 60 F8. That is the question. So data he has given data is the 60 diameter lies in the step of 50 and 80. Diameter 60 is a basic size, lies between 50 and 80 mm. So first step is, you need to calculate D equal to cube root of D1 and D2, that is equal to square root of geometric mean of 50 and 80. So whatever value you will get, that is a D, 63.25 mm. So we calculated D. Then he has given fundamental tolerance unit. So fundamental tolerance unit, because they will allow calculator in exam, so you can solve any type of complex calculation. So tolerance unit is I, equal to 0.45 d power 1 by 3 plus 0.001 into d. These are all in microns. 10 power minus 6 meters microns means. Substitute the value, then you will get I equal to, substitute D equal to 63.25 then I equal to 1.856 into 10 power minus 6 meters. So he has also given tolerance value for IT8. So as we have seen 60 F8, F8 means IT8. So tolerance value of shaft, equal to IT8, that is equal to 25I from the design handbook. So 25 into I value is 1.856 into 10 power minus 6. So you will get the value is 46.4 into 10 power minus 6 meters. That is tolerance of shaft. Next, fundamental deviation of shaft he has given. Fundamental deviation of shaft is equal to minus 5.5 into d power 0.41 micro mm. So substitute the d equal to 60, fundamental deviation fd equal to minus 5.5 into 63.25 whole power 0.41 micrometers. Substitute this value, you will get 0.030 mm fundamental deviation. So we got the values. So now draw the graph. So they have given only information related to shaft. So first draw the basic size. Then he has given base deviation of shaft, so which is negative, this one. So negative means it is below. Fundamental deviation is negative means it is below. So we are drawing the graph below that. So this is the data we have only related to shaft. So this is shaft tolerance. How much is that? So 0.046 mm, 464. Next, this one is fundamental deviation of shaft. Deviation of shaft, fundamental deviation, which is how much? Minus 0.030. Minus means because it is below the basic line. Below the basic line is always called negative values. Basic size, basic line. This is below basic line. So whatever the values you will get below basic line is called, will be denoted as negative. So what he is asking, now we calculated all values, all are in mm, and now we need to calculate upper and lower limit of shaft. So basic size equal to 60, and upper limit of shaft is this one, and lower limit of shaft is here. So upper limit of shaft equal to basic size below, right? So anyway, basic size minus fund deviation. If you take deviation positive, a plus otherwise. So below value it has to be negative. So 60 minus 0.030. don't remember the formula, remember from calculation from diagram, then only you can solve it. So upper limit is 59.97 mm. So lower limit of shaft. So if you know the concept, you can solve any problem. Otherwise, if you remember the formula, the problems will vary every time. Sorry. Upper limit of shaft minus tolerance is a lower limit. So upper limit is 59.97 minus tolerance 0.0464, that is equal to 924 mm. So these are the upper and lower limit of shaft. It's 2 marks. It won't take much time if you know the fundamentals of fit calculation. Next topic is types of assembly. So we manufactured component, so we need to assemble. So how we have to assemble? First one is make to suit assembly. Make to suit assembly. So here one part is made nearer to the required dimension of the other part, which is already made. So first we manufacture either hole or shaft, depending upon the which system we are using. Then other part has to be manufactured depending upon the fit you need to do. So one part is made nearer to the required dimension of the other part. Other part which is already made. So this is make to suit assembly. Next one is interchangeable assembly. The parts manufactured here are interchangeable. Interchangeable assembly. The parts manufactured are interchangeable. So parts manufactured are interchangeable. This may be factory level interchangeability, means parts manufactured within company are interchangeable. National level interchangeability or international level interchangeability, depending upon the standards we are using. National level interchangeability, international level interchangeability. So what is international level interchangeability? So international level, suppose if a part manufactured in India, if maintain the standards of international standards, then the mating part can be manufactured in Malaysia, then both can be used for assembly. That's what it means. International level assembly, the part manufactured at different locations in the world can be assembled if they follow the international standards of manufacturing. Selective assembly. selective assembly means here the selective group of components are interchangeable. Not all components, only selective group of components are interchangeable. Very small tolerances are given here. Selective assembly. Only selective group of components are interchangeable. Only selective group of components are interchangeable. This is about types of assembly and how them after manufacturing what it will takes place. Next is, so once the component is manufactured, we need to inspect the component such that whether the component is meeting our requirement or not. So if it is defective or not, all those things you have to check. Then only you will send it to final product. Otherwise, if the if it is product is defective, then you need to stop the production and again check the where you are doing mistake, where the error is coming out. So that's what. So to inspect the component, then we use two methods of inspection. So in methods of inspection, first method is inspection by variables. So what it means is, suppose I manufactured a shaft. So I measure by taking scale what is the diameter, what is the length, all this. So measure each and every dimension physically by using some equipment. Measure each and every dimension physically by using equipment, whether it may be scale or steel rule, which is same, or vernier calipers, screw gauge. So it is physical measurement. You will check the length, diameter. So this is inspection by variables. Next method is inspection by attributes. So here instead of measuring, we use limit gauges. So limit gauges are used to inspect by attributes. The dimension is not measured, but the decision accepted or rejected are based on the entry of the gauges. Limit gauges are used to inspect the attributes. Limit gauges are used to inspect a component. So what are these limit gauges? So limit gauges are, for example, if you want to inspect a shaft, then you have to take a gauge, ring gauge, which is opposite dimension to the shaft, that means which is hole shape. So you have to insert the shaft into that gauge. If it is going, that gauge is also two types, go gauge and no go gauge. So the shaft has to enter into the go gauge, then you have to accept, and the shaft does not have to enter into the no go gauge, then that component is accepted. So gauges are used to measure the inspect the component. Two types of gauges, one is go gauge and another one is no go gauge. Go gauge So go gauge enters into the component acceptable components. Go gauge enters into acceptable component. So no go gauge not enters into the acceptable component. If no go gauge enters, then it is not accepted, it is rejected. So no go gauge not enters into acceptable component. Suppose if I want to inspect a hole, then I use plug gauges. The whatever the component, if you want to inspect the component, the gauge is opposite to the shape of the component. Suppose if you want to inspect the shaft, then it is hole shape, the gauge is hole shape. If you want to inspect the hole, then the gauge is in a shaft shape. So go gauge, suppose for example if I am inspecting a hole, I am using a plug gauge which is shape as similar to the shaft, so that both go gauge and no go gauge are the same shape. And if go gauge enters into the component, it is accepted, and again you have to check with no go gauge, and no go gauge does not has to it doesn't have to enter into the hole, then the component is accepted. So first inspection is inspection by attributes, then we go for inspection by variables. First we need to check with inspection by attributes, that means gauges. Then inspection by variables. So inspection by attributes, why we need to do first inspection by attributes only, why not inspection by variables? Suppose if you have done inspection by variables, such that for the component you manufactured, you measured all the dimensions with whatever the equipment, then you have inspected using gauges, so it came as rejected in gauges, so then the time you spend on inspection by variables is waste. So to avoid that, we inspect by attributes first, like go gauge and no go gauge. If the component is accepted there, then only we inspect by variables. That's a fundamental behind this. So what are the gauges we use for go gauge or no go gauge? For inspection by shaft and inspecting by hole, that we need to study. So holes are inspected by plug gauges. So plug gauge used to inspect holes. So this shape is similar to the shaft shape. This is plug gauge. It's like shaft. Depending upon the component which we are inspecting, the opposite structure will be there. This is go gauge, no go gauge. Some values is